my presentation with a little demonstration. Colin, can you pick an object in this room, preferably inorganic?
Mr. Weiss on his desk.
Okay, this desk here has many parts that you can see, but it's one system. The system itself was designed by a mechanical engineer who figured out the stress points and the geometry necessary to create this whole desk. But then the individual components were also worked on by different mechanical engineers. The pressed wood, it's obviously not real wood, so somebody had to figure out how to create a composite wood that would be a good desk surface. Somebody had to create the sheet metal. Somebody had to create the handles on the drawers, the rollers in the drawers. Every part of this was worked on by a mechanical engineer. So mechanical engineering really is very wide-ranging. Specifically, what is mechanical engineering? Mechanical engineering is the discipline that applies the principles of engineering, physics, and material science for the design, analysis, manufacturing, and maintenance of mechanical systems. It is the branch of engineering that involves the design, production, and operation of machinery. It's a very long dictionary way of saying, in short, it is the application of science to any and everything around you. And it quite literally is anything. The mechanical engineering field in universities typically has as many as 26 subfields. Now, I'm obviously not interested in all of them, but there are quite a few that I am interested in, and I have been doing some really diverse research this year. So, with all of these different options, it seems kind of daunting. You don't really have any set guide of what you should do, but that's kind of what I like about it. It's the freedom of discovery and intellectual curiosity. So my quote for this year that kind of guides everything that I've been doing is from Leonardo da Vinci. He said, it had long since come to my attention that people of accomplishment rarely sat back and let things happen to them. They went out and happened to things. That's my goal, not only for this year, but really for the rest of my life, to happen to things. Another quote says, there are no actions, only reactions. But I don't think that's true. I think that you can go out and you can create actions. You can create change. That's what I'd like to do this year. My guiding statement for this year is very long, so I'm not going to read all of that. But basically, it says, I will learn the skills that allow me to happen to things. It doesn't make sense as a mission statement, but you can see it goes with the quote. So some of the research assessments that I've done this year, they're very diverse. Like I said, 26 subspecialties, not really sold on any one of them. So I have very broad interests. The key point of most of my research assessments has been curiosity about any subject that I like or that I think could be interesting. So I've learned about things as diverse as 3D printing and STEM education as a field. There are a few central themes to my research. There is the future of engineering, where it's going, what you can do with it in the future. And there's also the process of engineering. How do you get the best results and create the best products? So my very first assessment was on 3D printing. It was a write-up about a meeting of the American Society of Mechanical Engineers where they discussed the future of 3D printing as a whole. And 3D printing itself is a very diverse field. There's metal 3D printing, textile 3D printing, people are even trying food. So they talked about the broadening possibilities, all the things that you can do with it in the future. They also talked about the diversity of materials. And the central thing that was a big topic this year was the internet connectivity, this so-called Internet of Things that we all hear about. So if you can connect your 3D printers around the world to the internet, you can create a product anywhere using intellectual property created anywhere else. If you are on a ship in the middle of the ocean and a part breaks, you can 3D print a new one using a file emailed to you by someone back home. It's really a field with endless possibilities and will be really interesting to see how that develops. My next research assessment was very far removed from that. It was about hybrid optimization with heuristic methods. So a group of mechanical engineers and mathematicians from the University of Bath in England figured out a mathematical equation to better switch between hybrid electric and hybrid fuel in vehicles. With their theoretical model, they determined they could get up to 19.07% efficiency improvements with a simple mathematical equation. When they implemented it, they found that it worked incredibly well. They achieved exactly what they thought they would. And it's really interesting that mechanical engineering doesn't have to be the gears and the metals and the pieces. It can be the theoretical concepts of what they call heuristic models. Haven't quite figured that one out. I think that's a next level word. Humanitarian engineering was actually based on a TED Talk that I watched with an Indian doctor of mechanical engineering who ran a program out of one of the big technological schools there. He would come up with ideas that would benefit the many. He talked about how there's a tendency in engineering to work towards more money rather than more benefit for more people. And he would theorize products that could help the most number of people. His first product was a very inexpensive car that could be used by regular village people in third world countries to transport their goods to market, to get themselves to health care. The access to a vehicle is very important for progressing in your society, but it's very, very expensive. All of the car companies told him it couldn't be done, but he used a small group of very invested engineers. These are people who came from these villages in India and had a vested interest in improving their community. And because they had the freedom of thought, they had no limitations on the product, they were allowed to explore different possibilities. Nothing was unquestionable. And they came up with a perfect solution. For $2,000, they created a perfectly operable car. I also researched community innovation, what we might call crowdsourcing. And that talked about the nature of competition for creating the best products. When you're in competition with other people, you come up with more creative ideas. There's also just the simple fact of man hours. When you open a product up to so many people, you get so many more man hours thinking of things, and you also have more diversity of thought. But another thing that's important in engineering is the representation on the team. The better it represents the market, the better the product is, because people will know what they want. My final research assessment was on STEM education. It's something that we all hear so much about, and nobody really understands. It's a buzzword. This research talked about, it was from the University of West Virginia, and it talked about how the way that we do things in education doesn't really mirror the way that we do things in the industry. In the industry, like Julie talked about earlier, everything is incorporated. You have mechanical engineers with software engineers and other types of fields. But with our education system, things tend to be specialized. So they've created an integrative approach that better represents what real work is like. So some of my interviews, I've only had 3 so far, but they've been with professors at SMU and UTD. They have been very interesting. Maybe I'd say I have a favorite, but they all have very wide-ranging experience. I never met with anybody who started as a mechanical engineer, and that's something I'll talk about here. I met with a person who started as an electrical engineer, one who started as a nuclear engineer, and one who started as a naval engineer. They're all in mechanical engineering now. They all do research at their universities, and they all place an emphasis on curiosity as very important to success in engineering. My first interview was with Dr. Bruce Guinée. He works at UTD, and he's the head of all of the research that they do there. He started as an electrical engineer, with background in nuclear engineering as well, specifically electronuclear engineering. And his work now is in mechanical engineering. He's working on a product for the Department of Defense where they've created new devices that detect nuclear material here in America. So he's detecting nuclear bombs on US soil. It's very cool. My second interview was with Dr. Ali Beshkak. He is the chair of mechanical engineering at SMU, and he also does lots of research. He showed me his lab. He's working on a system that plugs into your smartphone and can detect cancer with just a small droplet of blood. It was incredible. You could see it's on the microscopic level. Dr. Volkan Otugan was a phone interview that I did. He stressed to me that he's not actually in the Department of Mechanical Engineering anymore, but he was for many years. He was in fact the chair of it, like Dr. Bashkog. He's now the assistant dean of all engineering at SMU. He also does research in microfluidics. Over my head so far. So I've learned so much with what I've done so far, but there's a couple things that I know I need to work on, and I'm hoping some of you can be my partners in improving. I need to find a mentor fairly soon, right? And I need to work on my website. So if you could all do me a favor and remind me of these things going forward to help me be successful. As I progress, there are a couple things that I'd like to do. I really want to emphasize hands-on learning in the moment, with actual applications. But as I learn, I want to do deep dives into anything that piques my curiosity. I want to continue to have intellectual curiosity and diversity of thought. So a quick preview of what I'm thinking for the rest of the year. I would like to build an electric car. It's a kit that uses a system developed specifically for learning engineering. And I think that it will be so much learning about every system of it, and I can expand that learning to all of the different systems and the principles, and that's the kind of deep dive that I want to do. I think it'll be a really interesting year, and I should learn a lot. Thank you all for listening, and thank you for your help in the future.